A warm good evening, class. As a small glimpse, we have talked in an introduction about this time, temperature, and transformation diagram. Today, in this video, we are going to see much deeper, right? So let's go inside. So as I already indicates, this time, temperature, transformation diagram mostly is taking place under Utah temperature, which is around 730 degrees Celsius. So the whole process taking place the below the detector temperature, which is below 727 degrees Celsius, and that too above detector temperature you can see it is completely austenite structure from cooling. So here you can see from gamma to pearlite, gamma to bainite, gamma to martensite, means this gamma is nothing but austenite. So here if we need this coarse pearlite microstructure, okay, if we need a coarse pearlite microstructure, we'll take them first we'll heat the material up to 800 degrees Celsius or 1000 degrees Celsius in the making the material to reach the austenite zone. From there, if we slowly cool towards this, slowly cool the material, and if we reach at this point where the transformation going to start, right? And upon reaching state, towards this point, you can see the transformation going to. What this transformation, the transformation that happens is nothing but gamma is transferred to pearlite. So if so, upon slow cooling, means on slow cooling you will get coarse pearlite, which because on slow cooling means if you're cooling very slowly means that there is a heat prevailing inside the material. So still the heat is prevailing, you can see the material expands and sometimes recrystallize. So on expanding you can see the fine grained microstructure is converted into coarse grained microstructure. So if we take from 800 degrees Celsius upon slow cooling, if we touch here and upon slow cooling you can see you will find the coarse pearlite microstructure. So here the importance of pearlite is that most of the steel grades have this pearlite as the common microstructure in it. You can see the mild steels or any steel which is available in the market. You can see some pearlite regions will be there inside the microstructure. Okay. The next one is that if I need a fine pearlite, means that I have to from 800 degrees Celsius I have to cool it fastly to this to this point, something around 550 or 580. Then I have to expand it towards it, sorry, hold it towards it, and I have to cool down to the fine pearlite region. So here you can see when compared to the coarse pearlite, I get a fine pearlite, which because this coarse pearlite, which because the coarse pearlite, you can say coarse pearlite is due to slow cooling, and comparatively it is this fine pearlite region is has been done due to the fast cooling process. Here you can see this compared to this fast cooling, you can it is fast cooling. You can see the fine structure forms because on fast cooling the heat will be dispatched or moved out quickly, so that the grain growth is stopped there. So comparatively you can get the fine pearlite region in this the temperature around 5 degrees Celsius. So next one, if I need bainite, okay, then I have to cool it much faster when compared to pearlite. I have to reach it here fastly from 800 to around 350 or 400 degrees Celsius. Then I have to hold it there where the transformation takes place. Then I have to cool it up. So here, if I need the bainite microstructure to happen, I can move like this as I mentioned before. Next, martensite. If I need the martensite is the most hardened or the microstructure which has a high hardness. It is martensite. So if I need martensite microstructure, because you can say why are you using very hard microstructures. Here you can see if you are going to any application which is related to earth movers or something where the hardness and strength plays the major role, where then in that places we need martensite. So here you can see from 800, if we suddenly cool towards ms temperature, ms is around 210 degrees Celsius. You can see if we cool it suddenly here at touching this point, this austenite is completely converted, started transformation to martensite. And upon this fast cooling, you can see the martensite will be completely, so this austenite will be completely converted to martensite. So the martensite is the hardest structure, which because of its very fine grained microstructure, it is due to the fast cooling rate. So there won't be any grain expansion, so that the very fast martensite formation occurs in this temperature. As a short, we can say on slow cooling you can get pearlite, on moderate cooling we get bainite, and on fast cooling we'll get martensite. Okay, that's all for about time temperature transformation curve. We'll see the cooling curve transformation curve in the next video. Thank you.